Chapter number 1: Numbers Quantification and Numerical Application. Introduction. Recall how we classify a number as either odd or even, but not both. Consider a set of 10 consecutive positive integers and classify them as even or odd integers. This classification of the integers into two sets as the numbers selected are either even or odd. Our statement can also be understood as dividing the numbers into two classes on the basis of their divisibility by 2. That is, if number leaves the remainder 0 and it is classified as an even number, and if it is leaving the remainder 1, then it's classified as an odd number. Thus, we are only dealing with remainders as the basis of classify the numbers as even or odd. Let us explore the concept of classification with the following examples. Illustration 1. If today is Wednesday, then what will be the day after 68 days? Solution. A week is cyclic in nature and repeats itself after every 7 days. When we divide 68 by 7, the remainder is 5. 68 is equal to 9 weeks and 5 days. Thus, after 5 days from Wednesday, it will be Monday. Thus, the day after 68 days from today will be the same as 5 days from after Wednesday. Hence, 68 days from today, that is Wednesday, will be Monday. Topic 1.1: Modular Arithmetic. A system of arithmetic for integers which deals with remainders only is known as modular arithmetic. We have learned Eccles division algorithm in previous classes. It states that dividend is equal to divisor into quotient plus remainder. Given two positive integers x and y such that x is greater than y and y is not equal to 0, then x is equals to y into q plus r, where x is the dividend, y is a divisor and q is a quotient. R is equal to remainder. Modulo operator. Given two integers x and y, where x is greater than y and y is not equal to 0, x is equal to y into q plus r. Then there exist two unique integers q and r such that the same expression can be written as x mod y is equals to r, where mod in bracket modulo gives the remainder x is divided by y. For example, 29 mod 3 is equal to 2. When 29 is divided by 3, it leaves the remainder 2. Consider a 12-hour display wall clock. Here, 13 o'clock in the morning is displayed as 1 o'clock as 13 is equals to 12 into 1 plus 1. Or we can say 13 mod 12 is equals to 1. Basically, in such cases, it does not matter how many times an R and goes around, but where it ends up. Modulo operator is a mathematical operator which gives the value of remainder when a positive integer x is divided by another positive integer y. It is written as modulo or mod and is represented as equation 1. Note that x, y, and q can either be positive, negative, or even 0 if we exclude y, whereas r can only be non-negative. Let us understand the conditions with the help of examples. Cases: if x is greater than 0 and y is greater than 0, 68 mod 12 is equals to 8, then r is equals to 8 is greater than 0. If x is lesser than 0 and y is greater than 0, minus 68 mod 12 is equals to 4, where r is equals to 4 is greater than 0. If x is greater than 0 and y is lesser than 0, then 68 mod minus 12 is equals to 8, where r is equals to 8 is greater than 0. If 0 is greater than x and if 0 is greater than y, then minus 68 mod minus 12 is equals to 4. R is equals to 4 is greater than 0. When x is equal to y, then x mod y is equal to 0. For example, 3 mod 3 is equal to 0. When y is greater than x, then x mod y is equals to x. For example, 7 mod 13 is equals to 7. Example 1. Find 21 mod 8. Solution. First, 21 is equals to 8 into 2 plus 5. Remainder is equals to 5. So 21 mod 8 is equals to 5. Second, minus 31 mod 7. Minus 31 is equals to 7 into minus 5 plus 4. So minus 31 mod 7 is equals to 4. 18 mod 18. 18 mod 18 is equals to 0. 7 mod 12. 7 mod 12 is equals to 7. Properties of modulo operator. Property 1. If the value of x is increased by a multiple of y, say ky, where k is an integer, then x mod y is equals to x plus ky mod y, where k is an integer. Example 2. If x is equal to 7 and y is equal to 3, then verify that x mod y is equal to x plus ky mod y for k is equal to 6. Solution. For given x is equal to 7 and y is equal to 3, x mod y is equal to 7 is equal to 7 mod 3, which is equal to 1. Also, x plus ky mod y is equal to 7 plus 6 into 3 mod 3, which is equal to 25 mod 3 is equal to 1, as 25 is equal to 8 into 3 plus 1. Therefore, 7 mod 3 is equal to 25 mod 3 is equal to 1, hence verified. Illustration 2. Use information of table 1 to compete with table 2. X is equal to 18, y is equal to 5, x mod y is equal to 3. K 4, 7, 8 minus 2 minus 4, 12. Ky 20, say 35, 0 minus 10, 0, 60. X plus ky 0, 53, 40, 8, 0, 0. K plus x plus ky mod y 0, 3, 0, 3, 0, 0. Observation. Compare the value of x mod y with x plus ky mod y. Property 2. Addition property of modulo arithmetic is if a, b and c are positive integers, then a plus b mod c is equals to a mod c plus b mod c into mod c.